Hi, this is Lacey Phillips, and
Robin Haag.
we are in Glasgow at COP26. We're here with Bloomberg Green's set of conferences and sessions. So if you haven't checked out their magazine, it's pretty cool. Cool color scheme and good content. So that's always a plus. So we wanted to share a little bit about some of the themes and content that we're hearing about. And we'll start off. So the session this morning, some of the correspondents from Bloomberg Green gave a recap of week one. So we're now in week two of COP26, but last week there was a whole set of sessions. And we'll get to some of the details of everything they talked about, but one thing that was on the list of top topics, highlights from last week, was the topic of methane. And so if you're like me, I thought, when I first heard about methane, I thought, oh my God, right? I thought it was just carbon. Why do we have to start worrying about other things as well? But it's an important topic, and there's been a methane agreement made here at COP26. Some things to dive into, but first I wanted to turn it over to Robin to talk about what is methane, why do we need to care about it? Is it a vanity topic? What's give us the cut through the drama and the buzzwords.
Yeah, so we need to go a little bit into climate science here. So basically, each greenhouse gas has a global warming potential, and you measure it in reference to CO2, to carbon dioxide. And what most people hear about is that, oh, methane is 20 times as bad as carbon, right? But that's very simplistic. It just measures the time at basically after the impact at 100 years out. But the interesting thing is that the impact distribution over time of carbon dioxide versus methane is very different, right? So methane quickly has an impact on temperature, and then the impact kind of dies down, whereas carbon has an increasing effect over time up to 100 plus years out. So when you look at 20-year impacts, so shorter term impacts or one generation impacts, methane is actually about 80 times as impactful as carbon, right? So if you want to have positive impact on climate within one generation, it's actually much more effective to take methane out of the atmosphere than taking carbon out of the atmosphere.
Or never release it to begin with.
Right.
So do you know, where would we see methane? Who's emitting methane? How is it different than carbon, and from a practical landscape perspective?
Right. So, for example, landfills, right? Just trash sitting around. You have, oftentimes people say that the cow's farting, right, is one thing, but that's actually, there's the digestion, but that's actually a minor portion. It's it's more, people like to make fun of it. But then also, for example, flares of oil and gas fields, right?
Oh, okay.
Yeah.
Interesting. And then what should a business leader be thinking about? How do they productively engage in the conversation around methane? What should they know? What do they not need to worry about?
Well, first of all, it's important, as with any greenhouse gas, right, it's important to take an inventory, like an 80-20 inventory of where and what your emissions are across scope 1, 2, and 3, which we can do a separate session on. And yeah, really know kind of where are you contributing to the pollution, and then see if you can fix it pretty quickly. You might even save money in the process, right? Like if you take the carbon or the greenhouse gas lens to business activities, you often realize cost savings that you wouldn't have realized by just looking from a cost angle, right?
Yeah. So then, so let's say, we've looked at all of that. Is that where it ends? Carbon and methane, and then we're done? Or are there more sneaky gases?
No, of course, there's very sneaky gases in, for example, in ACs, right? It's a massive opportunity and risk, the way that we dismantle ACs and
air conditioners.
Got it. And which fluids we use for that, et cetera, yeah, and others as well.
Okay, maybe we need to do a longer session to know, what's the MECE set of gases that people need to worry about? What does it mean,
I don't know if you want to be collectively exhaustive, but maybe the 80-20 approach.
Yeah, 80-20 would be nice, just to know, if I've gotten carbon and methane under control, then in 5 years, is there going to be a new in vogue gas that I need to suddenly, people are rioting because I'm emitting this gas, and it, we didn't solve the problem, right?
Yeah.
At the end. So, but just to recap, so it sounds like methane has a bigger short-term impact on temperature, global temperature.
Yes.
So,
If
but
we want to have
shorter half-life.
Yeah, if we want to have a decent shot, right? And I say decent shot at staying below 2 degrees, right? Have a certain probability of staying below 2 degrees, then basically methane is critical. Yeah.
And then one other thing I did want to bring up, and we haven't looked into detail at this yet, but so it sounds like there is a methane agreement that's been made at COP26. However, some of the biggest emitters of methane, like China and India, are not signatories, so they haven't signed that agreement. So I think somebody needs to do some quick math to understand what's the impact of the agreement. Like, did everybody sign it who doesn't emit methane? Does it mean anything? Certainly there's probably still work to do if the biggest emitters didn't sign it, but kind of like, so what of
well, if I heard the Bloomberg Green reporters correctly, they were saying that with the most recent contribution or commitments, we were at a median or like expected value of 1.8 degrees by 2100.
Right.
Obviously, with
to 3 degrees.
Very wide confidence interval there.
Yeah.
But they were also saying that basically the nationally determined contributions, or basically their commitments or pledges, are very hard to compare. Right. Net zero doesn't mean the same thing to everyone.
Right. Yeah. Okay. We'll stop it there, and we'll come back later with some other content and other topics. But thanks for the rundown on methane, and we'll share more later.
Thank you.